Hello, everyone, and thank you all for joining. Welcome to the 5th episode of our live coding series. My name is Tanmay Bakshi. Now, today is going to be a really fun episode of live coding. We're going to be doing something that I personally find really fascinating. Now, the reason it's going to be fun is because we are going to be taking a video, specifically a video that represents a comic. And so this is a video where the comic, of course, is really long, and so the video scrolls from the top to the bottom over the course of, say, 7 or 8 minutes. Now, because it's scrolling, you're essentially just looking at an image, but someone else is scrolling the image for you. And that can kind of be off sometimes because you might read at a different pace, of course, and you just want that image so you can control it so that you can scroll it. And so that's the issue that Omer came to me with a couple of days ago. So he had this little video of someone else scrolling their comic, and we want to convert that to an image. Now, I found that a really fascinating challenge, and so that's why today we're going to be implementing the solution to that challenge in a variety of programming languages, actually, sort of using the best of all these different worlds. And so now, as you know, we're doing this today. I'm going to be implementing this alongside my friend Omer. So quickly, Omer, would you like to introduce yourself before we begin?
Hi, my name is Omer Kamal. I'm a software developer at IBM,
Perfect.
and let's get this started.
All right, sounds good. Also, just so you know, everybody, again, this is the 5th episode of the live coding series. We hold this every Wednesday in the morning Eastern time, and so if you would like to be notified whenever we actually start another stream, make sure you subscribe to the channel and turn on notifications. That way you actually know when we're streaming. There's a lot of really exciting content planned for the next couple of days, and so make sure that you do subscribe so you know when we're actually streaming or releasing new content. All right, so let's go ahead and get started. Now today, what we're going to do is we are going to start off by implementing this task in the languages Swift, Python, and C. Now, why the 3 languages, you may ask? Well, you'll see why exactly we're leveraging 3 distinct languages in just a moment. So what I'm going to do is I am going to switch over to my code over here, as well as share my screen with Omer so you can actually see it. There we go.
You should also mention that we're using command lines for one of the components
Yes,
for a reason.
we are actually using the command line for one of our components. I actually see a comment from Zeus here, and he says, "Will you be using FFmpeg?" Yes, we will be. Of course, that's a standard in the video encoding and decoding world. So FFmpeg, we're going to be using that in order to actually extract frames from the video. So what I'm going to do quickly first is just show you a sample of what kind of video we're working with. So this is a sample MP4 file that I've already downloaded locally. We can take a look at that. There is audio, which I probably want to use. Alright, there we go. So as you can see, this is the video. It's basically just a comic, but somebody else is scrolling it for you. Another interesting challenge here is there's a watermark in the bottom left corner. So we somehow also want to make it so that as we stitch together all these different frames, we can leverage the extra information that we get from scrolling in order to make sure that we don't have a watermark repeating across the screen. In fact, there's another one on the bottom right too. So by leveraging the extra information we get from scrolling, maybe there's a way that we can prevent having to keep that watermark too. So we're going to start off with Swift again, and then I'm going to hand it over to Omer, and Omer's going to show you how we can do something similar in Go. We'll take a look at the differences. As you know, for the past couple of episodes, we've been focusing on Golang quite a bit, but today we're doing things a little bit differently. All right, so as I mentioned, we're going to start off with Swift. So what I'm going to do is create a new Xcode project, which is going to be a simple command line tool. And the command line tool, we'll just call that video to Panorama. Create that on my desktop for now. It doesn't really matter where we put it. So let's start off with a little bit of Swift background. Now, just so you know, within the world of Swift, thanks to the Swift for TensorFlow project, there's actually this new series, well, there's this new, not series of tools, but there's this new framework called PythonKit. And what PythonKit does, if I just bring it up over here, what PythonKit does is it makes it incredibly incredibly easy to interact with Python within Swift, because there's some things that Python does so well that there is no point trying to replicate them in another language. And so, like, for example, I'm just gonna, as we continue, download PythonKit. But as a good example, NumPy is just one of those packages that is so optimized and so many people have worked on it for so many years that there's no point trying to redo what NumPy already does for you. And so what I'm going to do is quickly install the PythonKit Swift package, which Xcode handles for me, luckily now. Before you have to do the whole Swift package initialization from command line and insert it into your dependencies and stuff, but now Xcode handles that for me, just like that. So now within Xcode, all I need to do really is just import PythonKit, and suddenly I can take advantage of NumPy within Python, like that. Now technically, because the C Python interpreter is written in C, I could also call Python directly from C and we could eliminate the need for Swift altogether. But alongside performance, we've also got to keep an account that we don't want to spend a week implementing this. And implementing NumPy within C definitely takes a lot longer than just calling the Python bindings from Swift. So we're getting a good balance between performance and ease of implementation. Another thing I'm going to import is the pillow.image package. This will allow us to actually read images into memory from files. So now that we've got image and NumPy loaded, we're going to start off with a relatively simple task. We're going to take the video file, and we're going to extract frames from the video file, but we're going to remove duplicate frames, because if you take a look at this video, it's a mute the audio, but it's a 30 frames per second video. And that means when there's no scrolling happening, you just have continuous sections of many frames that are the exact same. We don't want to waste time exporting all of those extra frames, importing all of those extra frames, and doing extra computation. So instead of having 12,000 frames, we can just get 100 unique frames. So a lot more computationally efficient. So Omer, do you want to go ahead and explain how the FFmpeg command works to do that?
Yeah, let me send you the command, and then from there we can work from it.
Perfect.
I will send you the way in Golang, since this is how I wrote it so far.
Perfect. Well, we only really need the command, and then I can call it from Swift.
Yeah. Let me send you over Slack.
Sure. There we are. Okay, so I'm in my terminal. And there we go. So I see it's in a bunch of different parameters, but
yes,
we can fix that.
You should put that check file.
Okay.
Oh, you actually do need the quotation.
Yeah,
I want that.
I got it. Sorry, I'm just reformatting this command. So if we just do a little bit more here, and then just quickly, come on, keyboard.
Oh, you can do shift and then continue. Oh, skip a few lines.
Oh, can I? Okay.
If you like characters.
Next time.
So what this command does is we're gonna be calling FFmpeg. We did try to implement this ourselves. The library is actually pretty bad. Even in Golang, I couldn't get similar performance even calling this directly. So it's faster just to call the binary. -I is the MP4. -VF, that's just a filter that we're gonna apply, and this is the filter that we're gonna apply, which is get all the unique frames, and then we also want to output it as images, as PMP or bitmap pixels, and from that we're gonna take all these files and load that into memory and continue using the images there. So we don't need to compute the frames ourselves.
Yep, and also just really quickly, the reason we're using BMP outputs, the reason we're using bitmap output, is because it's pretty raw, and so there's no like lossy encoding, and it takes up a lot of file size, which means that it's very, very easy to encode. Right, with JPEG you have to compute the compression and then save, but with BMP you're just outputting raw pixels essentially, and so it's a lot faster.
Yeah. if you skip the header, you can just load the whole thing into memory, and with most languages, you can just have that as a bitmap.
That would be
So
fun
in
to
Golang,
do.
you can take the whole chunk and just load it in. If you
Interesting.
once you skip the header.
Okay, well, yeah. But this video isn't about reading or decoding bitmap files. This is about stitching together a comic.
Maybe another video.
Yeah, maybe another video. But yes, as I was saying, if we go ahead and run this command, we should get a bunch of unique frames, in theory. And of course, do I not have VI mode? Okay, well, I need to do that. So what I'm going to do is call the FFmpeg binary that I actually have stored locally in this directory.
Oh, you didn't install it?
No, I didn't, because on macOS Big Sur installing things is, because it's a beta release, is not easy.
Oh, I see. Because I just did brew install. Everything was working fine for me.
Yeah, but not on the beta OS.
You should move to the stable.
Well, okay. So as you can see, we are now able to take that video, and so far, even though we've gone through quite a bit of the video, actually the whole video, we've only extracted 115 frames, whereas it's actually 8 minutes and 20 seconds long, which means it's 500 seconds long, which means we should have extracted around 15,000. And so there were lots of duplicate frames that FFmpeg just helped us reduce immediately. So if I go ahead and open up this folder in Finder, you can actually see that we have all these different bitmap files, and they all have some sort of change from the last frame. And because of that, our compute is going to be a lot more efficient. Now, we somehow need to take these bitmap files and stitch them together into a single bitmap file. How do we do that? Well, here's where the really fun logic comes in. So, here's the idea. Let's just say we have these two frames. We know that the second frame, file 2, occurs after file 1. We know that there was some sort of scroll happening. We don't know how much it scrolled. We don't know in which direction it scrolled. Did they scroll up or down? So what we're going to do is we're actually going to take file 2 and file 1, and we're going to consecutively move file 2 on top of file 1 as sort of like a sliding window. And wherever file 2 and file 1 intersect, we're going to take the difference between those two sets of pixels, we're going to average them. So the absolute difference is going to be averaged. So we can see how much that little sort of overlap matches. When we find a section of overlap that matches incredibly well, we know that we've been able to tile these two images on top of each other really well. And that means that we've found the delta between the two images. We've found how much we've scrolled from file 1 to file 2. Then if we do that for file 2 and file 3, and 3 and 4, and 4 and 5, and so on and so forth, then we have all of the scroll deltas, whether you're moving up or down. You could scroll all the way back, all the way down. You could scroll back up and back down. We would know that you went back up. We would have that sort of virtually stored within memory. And then we can use that alongside a little bit of other logic to compute the total height of the actual final resulting comic, and then store all the images, paste them on in a way that removes the watermark. So I feel like the best way to actually describe this would be to go ahead and implement it. But before we can implement it, we have to load the images themselves. So here's...
I do have a question.
What is the question?
The image preview you're using, is that the built-in one or is that a new one?
PIL image?
No, the one that you view in the images.
Like this? This is just Finder. This is Mac stuff.
Oh.
Yeah, if you just click spacebar on a file, it shows you the preview.
Oh, okay. Because I always use the preview and it doesn't even look like that. It's kind of bad.
So Zeus also mentions you just need to find the delta in the bottom 30% of the image. So very good idea for optimization, by the way. That's an incredible idea. But I will say, we tried that, and there are some frames where that does not work. For example, if we take a look here, there's one frame where there's a pretty big jump. Like I don't remember exactly where it is. But I know for a fact that within this example, oh, there it is. So look at this. This is file 29, this is 30. That's a huge jump. So if we were only taking a look at the bottom 30%, we wouldn't know how much it scrolled. In fact, this was a bug in a previous generation of this software. So we need to take a look at not necessarily the whole thing. Obviously, we're not going to have like 2 pixels at the top or 2 pixels at the bottom, but we want enough to cover even large scrolls. So that is what we're going to do. Now from there, we have to load in the images. Now remember, we need to be very, very mindful of performance here. So the way we're going to import images is really going to be in a way that's as fast as possible. So the first thing that I'm going to do is I'm going to create a struct called NumPy image. This structure is going to contain 2 values. So the first one is going to be a reference to the actual NumPy array. And so this is just a Python object. But then what I'm also going to do is store a pointer to the data. And so this is just going to be an unsafe mutable pointer to a uint8, so an unsigned 8-bit integer. So this can go from 0 to 255. And the reason we need to also keep the reference to the Python object is because let's just say we get a pointer to the data within the NumPy array. And we take that pointer and we store it in Swift. Now Python doesn't know that we have a reference to that pointer and doesn't know that we still need that. So when we release the Python object, the Python garbage collector comes in and says, hey, you're not using that. So it reclaims that memory. But here's the problem. We still have a pointer in Swift, and now that memory's been deinitialized.
Is it nowhere in Swift to tell the garbage collection not to touch that?
There theoretically is a way, but again, figuring out how to communicate with the Python garbage collector is not something that we want to do right now.
Okay. Can you do this in Swift at least? When you import C and other stuff, to not like remove this?
Well, remember C doesn't have garbage collection.
No. So what happens is in like Golang, when you import a lot of C stuff,
Yeah.
if you don't tell the garbage collector not to delete this object, it will go delete it.
So within Swift, what's interesting is because it uses automatic reference counting for memory handling, until there is no reference existing to a certain structure or something, it won't free the memory.
So even if it's a pointer to a pointer?
Even if it's a pointer to a pointer.
Okay.
As far as I know. A double pointer, I'm mostly sure, but single pointer, I know for a fact, will not be freed until all the references to that pointer are gone.
Okay, that's actually pretty interesting because in Golang, I don't believe it worked like that.
Yeah.
Because you usually lock, you tell C not to delete.
See, that's why Arc is so much better than garbage collection.
I'd rather go back to the data actually telling the garbage collector to delete something if I have the option.
Well,
it's just faster in some cases.
I guess. But the Golang garbage collector is pretty fast. In fact, I think it's the fastest.
Yeah, and I have nothing against it. It's just sometimes you do want the find and show.
Yeah.
Of like telling when to delete. One example is I was reading this like 20, 30 gigs of files, and somehow my memory would just keep going up and up and up and up. What happened is when I copied it, like the data was 1 byte of the data was copied from an array, like reference, and because of that 1 reference, the whole block was there. So I have to be very careful when I was writing that code just to make sure the memory get released. Because my laptop was just like, yeah, you don't have memory like you don't have enough memory really. So it was keep paging it.
Yep. Okay, so just also another comment I see on the live stream, Swift has a different solution than garbage collection. That's why it's faster than Android apps. I wouldn't say that Arc is the reason it's faster. Arc is definitely one of the contributing factors because with garbage collection, no matter how fast your garbage collection is, there's a visible pause in your application on every thread, eventually even the UI thread, where you're pausing for a little bit to garbage collect, and the users will notice that as a little bit of a pause in their application before things suddenly continue. Whereas with Arc, things are just automatically freed whenever you no longer need them. So there's never a certain moment where everything stops. It's just, it keeps happening alongside all of your other operations. So it's pretty nice. So so let me just explain this little line of code. So basically I'm using Pillow to open up my image file. I then convert that to a NumPy array, and then I get the mean on the last axis. The reason I do that is because the shape looks something like width, height, channels, where channels is RGB, but we want a grayscale value, so we just want to calculate the average over channels to get the grayscale, so we only have width, height. Now the reason we only want width, height is because within our logic to actually determine the scroll delta, We don't need a lot of extra information. We only need enough information to make the scroll delta work. And grayscale is easily more than enough. We don't need to do 3 times the computation.
So are we gonna reload the images back when we need to stitch them?
Are we gonna reload the?
Because right now we only saving the frame as grayscale, not the color vision.
Oh really? No,
But we can-
FFmpeg does. FFmpeg is saving them in color.
No. But when you load the frame, you only get in grayscale.
Yeah. So here's my
Yeah.
idea. As the rest of the computation goes on, or actually, no, you're right. What we should do instead probably is make it so that within np image we have a grayscale function that returns a new np image, where we just say return np image array self.array dot mean axis -1, and then we get a pointer to that.
So the thing is, we're gonna call that function twice then. We really only want to compute this once.
No,
Because
we're
we're
not.
checking the difference, right? Because you're gonna constantly get the grayscale value, unless the compiler deal with that.
No, so look, mean would have been called here anyway.
Mhm.
And so instead of calling it here, we just call it here. That way we have to make a copy before we call mean, which is totally fine.
Yeah, no, but what I mean is when we do the delta, we actually using the frame twice. And we gotta get the grayscale
Oh, so you're
back.
saying cache the grayscale version.
Yes.
Okay.
So
That's a good idea. So we'll store this, and we'll just do if let grayscale self.grayscale return grayscale. Otherwise, we store this and then return. I think that should work. Okay. So there are a couple of errors, but we'll fix them. So, oh yes, another thing. In Swift, structures cannot contain themselves because that creates an infinite memory thing. We can, however, contain a pointer to ourselves. So, even though I don't like doing this, we might end up having to do this. No, I'm not even sure if we. No, we can contain a pointer. We can contain a pointer.
you know what? We can take the performance set right now. It's only twice computed in grayscale.
Or
Also, how easy
hear me
is
out.
to-
Hear me out. All we do is switch to a class.
Wait, what? What is this? What is this?
Just
You know,
go-
I should really go back into like
What?
C++, so like go into Swift because I'm so not used to classes anymore.
Oh really?
Or we'll go like both of them together.
Yeah.
I'm just so used to just structs.
Yeah.
This is how you know you've been in Golang way too long.
Okay, so this error is not one we can fix right now, and I'll tell you why in a moment. So cannot assign value grayscale. Yeah. Grayscale. See, that's
What
how
we
you know I'm
can
used
do-
to Vim.
What we can do is we can just forget about it right now and just.
Yeah, there we go. It's done. It's fixed. We don't need to forget about it anymore.
Okay. 2 more errors.
So this error we cannot fix. The reason for that is this. When you convert a NumPy array to a pointer, a ctypes pointer, you call array.ctypes.data, and NumPy, in its infinite wisdom, will actually reply with an integer value. Not a pointer, it'll return an integer value that represents the address of that pointer.
Nice.
All right. So what's really annoying about that is that Swift loves to be as safe as possible. And because Swift is so good with safety, it's not going to let you convert that integer from an address to a pointer. So we have to have this really ugly hack of creating a C file with a single function that takes an integer and casts it to a pointer.
Oh, so this is the C component now. Ugly. Yeah, whatever.
Yeah. But anyway, um, I'll just call it v2p, and we're going to create a Swift bridging header, which will let us import C code into Swift. Within the bridging header, I'm just going to include my actual header file. Within my header file, I'll just create a little a little function declaration. So address to pointer, and we'll take the address. Does NumPy return an integer or a long, is what I'm wondering now.
I just assume an int.
Let's assume int for now. Although I have a feeling
Yeah.
NumPy's address is... What? Okay, we'll figure that out. But
It could be a
always change
long. It
It's
could be long, to be
probably a
honest.
long. I think on 64-bit systems, memory addresses are 64-bit. But
No, because I'm just thinking, is int by default always going to be 32? Oh, I haven't done C for a long time.
C is always 32.
Okay.
At least when you compile with Clang, it's always 32. Clang and GCC.
Okay.
Let's see. Yeah. No, it's complaining. It needs to be long.
It's probably long.
Yeah.
It will make no sense.
Oh wait, why didn't I write this in the bridging header now?
So what's the difference between the bridger header and actual C?
So the actual C files contain your C code, and the bridging header is where you import all the C declarations that you want Swift to be exposed to.
Okay, so it's very similar to how Python does it then, when you have to have like a different file.
Well, I haven't. The only way I've imported C code in Python is using C types and shared libraries. So.
Oh, okay. You can do a PYX, I think, and that can bridge the C code directly.
Okay, that's good. Okay, so then within Swift, integers are 64-bit. How convenient. And so what I can do is I can convert the Python integer to a Swift integer, and then I can call pointer to address, which is the function we just created, and this should compile. Cannot find pointer to address. Did I name the function something else? It's address to pointer.
Tell me, so I did a little search Google search. You can actually use JetBrains, so you can use the VI directly for Swift coding.
Wait, what?
You can use the JetBrains IDEs.
Well,
for,
yeah, of course, lots of different IDs support Swift, but Xcode has the best auto-completion for Swift.
Maybe you should try it because you can install the VI plugin, which you love.
I will definitely. I think Xcode also has a VI plugin.
Oh, then you should get it.
I definitely will. I actually made a mistake a little while ago where I was over here and I wanted to get to the end of the line and I was hitting WW as if I was in Vim. But anyhow.
I tried the VI plugin, but I was so used to using my mouse that it kind of slowed me down.
Mm-hmm. Well, once you get used to it, it works. All right.
No,
so
yeah. The funny thing is there was so many commands I like it about it, but in the same time, a simple copy and paste or even tab is like, oh, yeah, you have to actually do a function for that. You cannot just press tab.
Right.
I'm too old to relearn that, okay? You know.
Well,
maybe in my next life I'll learn VI.
It's never too late. Okay, so now we've got a NumPy image class that enables us to get a pointer to our image and also grayscaleify it.
Mm-hmm. Also, there's a question that Zeus mentioned, JetBrains is good for Java. I do also want to add on that it's probably the best IDE for Golang as well. I haven't found any other IDE that can even compare to it.
That's interesting to see.
What happened now?
So what I'm going to do is I'm just going to hard code the number of frames for now, and later we can change that. But I just want to see...
It's better than mine. What I did is I just put it into another folder, and I just went to the whole image and loaded.
Oh.
Yeah, I just load everything, because I know that only the frame will be in there, nothing else.
Yeah. Well... Oh, I just got to feed in my path now. So it's called... file and then the number.bmp. So just so that we actually use the result of this, I'm going to print out the array's shape as well as the index that we're on. So I'm going to go ahead and run this, and you'll see that it's going to be, it might be a little, it's going to be okay performance, But when I actually go ahead and crank up the optimization levels for both the C and the Swift compilers, then we're going to get actually acceptable performance. Why is it not printing anything out? Okay, there we go. Even that's actually not bad.
I feel like you just did a dash of fast on the C compile.
That's exactly what I was doing.
You don't know what's gonna happen. Oh, okay, it went fast.
Yeah, it was pretty fast. Definitely faster.
Next you know, it just removed all the load in the Axpa and just printed out.
Yep. Also, another question that I see is how do you contact me in terms of like mail or how do you reach out to me? So I will be sharing more contact towards the end, and there's also in the video description how you can contact me in case you would like to see that. But back to the code. All right, so there we go. We have the images loaded in. Now, once the images are loaded in, we actually have to use them. How are we going to use them? Well, we need to calculate the scroll delta. Now, here's the idea. Just like we don't need color information, we don't need complete spatial information either. So for example, to calculate the scroll between these two frames, we don't need to take into account every single column across all of these different rows. Because even just the middle would give us, even just like 8 pixels across the center, would give us enough information about the scroll delta that we don't need to calculate thousands of extra pixels worth of data.
The assumption is that they don't have a white line in the middle.
I've encountered that bug before, but
I have encountered something similar too.
Okay.
So as a frame of reference, there's one comment that's over 100 videos, so we've been testing it, and there was a lot of bugs that we hit from just an assumption that we created.
But we've been fixing them as we go along, and so now it's a pretty bug-free experience. Mostly, yes. But as I was saying, we go ahead and load image. But now we have to have a way to actually calculate the scroll delta. And this is where we come back to C, because we need this to be as fast as possible. Just so you know how fast we need this to be, I previously implemented this in pure Swift, and it was slower than C, because when you add an integer in Swift, Swift does out of bounds checking and overflow checking and things, and just those extra clock cycles for example, overflow checking was making my for loop so slow that the C version just blazed through that. So
maybe I should do the same thing in Golang.
That might be faster.
It might be. No, but the funny thing for mine is it's just doing the math operation that takes forever to get to Grayscale. I will show you once we get to the Golang aspect, like what the setup is. It's mostly about the same, but most of it is going to just be in Golang, not really into C, since we don't need to worry about a lot of the overhead that Swift might have added for safety.
Exactly. So how exactly do we calculate the scroll delta? So here's what I'm thinking the function header will be. So if we go ahead and type in, so it's going to return an integer, so we know how many pixels worth of scrolling we've done. It's going to be called calculate scroll delta. It's going to take 2 of these pointers to an old frame and the new frame. Or we can't call it new in C, seriously. We'll call it image 1 and image 2, all right? And then from there, we also want to take the width, height, and the crop width. So how many pixels across do we actually want to take for the scroll delta to be calculated? So now we need to actually calculate. One thing also to keep in mind is that a NumPy array has a shape. And so like you can have, as in this case, a 720 by 1280 NumPy array. But the thing about NumPy arrays is that that shape is extrapolated on there when you actually query the array. The raw storage of memory is not actually like a double pointer or a triple pointer or a quadruple pointer based off of your shape. That wouldn't really make any performance sense. Instead, what they do is they have a single one-dimensional pointer to the entire array in a flattened way, and then they sort of extrapolate that shape on there whenever you call it or whenever you subscript something, and they calculate the one-dimensional index. And so
the funny thing is on that is every time I go into any image file, like any language will come to images or frames, they always do that. They're just a 1D that if you want to do X, Y, just compute the offset and directly get it.
I mean, for performance, that's kind of necessary. You have like a 4K image. I mean, imagine having that millions and millions of pixels in like a 2 or 3 dimensional array. That would be really, really slow.
Because but on the same time, no. But the funny thing is, if you allocate too little memory, that's a big overhead. If you allocate too big of a memory, you might just kill it, because just finding that chunk of memory might be a lot of time just to find.
You're right. Just to find the page with all the memory that you need. But still, it's
fine.
Worth it in this case. And I'm sure NumPy has some fancy way of dealing with it.
Yeah.
Anyway.
It's probably just a simple, what is it? 3 color? No, you're doing 3 colors or 1 color right now?
For the input to this function is just 1 color.
Okay, it's not that big. It's only 720 by 1080, I think it is.
I think so.
It's not that big of an image.
So I'm also just really quickly going to run this code. We saw the performance with just loading the images was fast. But what about if we actually grayscale it? How much does that slow it down?
Slightly.
Noticeably, but not too bad because we only have 115 frames. So that took like what, 2-3 seconds to import? It wasn't too bad.
Yeah.
Anyhow, so within the calculate scroll delta function, one thing that we want to do is we want to have a for loop of all the different offsets. So we'll say offset equals, and we'll start off with like the height divided by 3, so we start off at a pretty low level. But then we want to continue until the offset is at like height times 2. No, times 2, I think. No, times 2. And then we're going to increment offset by 1 every time. As an optimize, no, never mind. I was going to say we could increment the offset by 2, but then if it's an odd number that it's offset by, then we're going to get little jerks in between the scrolls. But anyhow, so we have the offset there, and I'm also going to store the lowest error, which at this point will be width times height times 3, and I'm also going to store the lowest error delta, which so far has nothing in it. And that way, when we store our data, we can actually know which offset so far is the best offset at which the error is lowest. Okay, so from there, we need to actually calculate the error. So we're going to store error, which is currently going to be equal to 0. We're then going to, let's see here. So we have error equals 0. Now what's really convenient about this is both the images have the same height, and of course the same width, but that doesn't matter right now. It's the same height. So either, and this is really convenient, this is a use case specific optimization. What makes it so convenient is that at either sort of section, either it's going to be a section of the old image or a section of the new image, or entirely the old image or entirely the new image, in the sense that because the new image or the second image that we're actually overlaying on top of the old one, because that one isn't like smaller in height, we don't have these weird sections where it's a bunch of the old image and then that whole like new image, and then again we restart with the other pixels. So we can calculate the sort of offset point at which we either have the old image or the new image, which makes it so that so that we actually can implement this in a really fast way. Mm-hmm. So that's convenient in the way that the data is structured. And so, yeah.
There's also a question, Vinzu. Can we have a simple logic model of a SVM, so I'm guessing simple vector machine, to solve this problem?
I mean, I'm not sure if this is a machine learning problem. I don't think this is a machine learning problem.
I believe machine learning might just be more overhead.
I think it's definitely gonna be a lot slower. You could do it though. I think you could. If you were to use a very specific architecture, like a spatial transformer network or like a capsule network or something that actually takes like the shape of an object into account, then potentially,
So
but I
maybe,
don't see that immediately.
yeah, so I don't think it will probably affect to this one. There are cases where the video will also shift to left and right between each panels. Maybe in there will probably the performance set will be like good. Like if you do a performance of just up and down and left and right, it just might be too much to handle.
Mm-hmm.
Okay, you're gonna be scanning the whole images like a lot of times to check how much it moves.
Mm-hmm.
Okay, let's continue.
Okay, so I'm doing something that's a bit mind-bending, but it works. So, wait, does it work though?
It
I'm
does.
thinking.
It should.
So,
No, actually, Tammy, the thing
yeah.
is, we can make the assumption that the second frame are always going to move down. I think you also take into account that it can also move up. There might be cases that it move up slightly and then move back down.
Yeah, I'm making it so it moves up and down. Like, so we can handle both properly.
Mm-hmm.
So we're gonna assume that for now. Because if it scrolls up, that's a problem. If we don't handle that, it's gonna completely mess up the panorama. But so basically, what this logic is gonna do is we have to figure out at what pixel the old image and the new image actually start. But I'm trying to figure out if it should be the other way around. So let's just say the delta is less than 0. Then in that case, we want the new start to be equal to negative delta, not the old one. Oops. And the reason I think that makes sense is because the delta value represents how many pixels it scrolled up or down.
Mm-hmm.
So the delta is negative, meaning like the image starts off, like the top of the image is above the boundary of the image. Then the top actually starts down where it starts to intersect with the second image. Otherwise, the old start, yeah, that actually makes sense to me. Does it make sense to you, Omer?
Yeah.
Okay. So then we're going to start off with row 0, and this is just going to go until the entire height because we want to check all the different rows. But then for the column, here's what's interesting, is we only need to go from start x to end x, and we'll calculate that in a second. So
we do need to take into account that the height. Did we add that into this logic yet?
Sorry, what height?
Never mind. Because the thing is, we're gonna have two different heights for each of the images. We want to see how similar they are, right?
Sorry, your audio was kind of cut out there. Can you say that again?
So what will happen is that when we align the two together, the heights are not 100% the same, like when you do the comparison. Because when you slide one up, you kind of crop in one.
Yeah, of course, and that's why we're also going to store another value called pix, which represents how many pixels we've added, so we average properly. Okay. So then what I'm going to do is just say pix plus equals crop width, and then error plus equals. So we have to create actually another function, which is going to be an inline function, just so it's like super fast. Again, the compiler would probably inline that for us, but just to be on the safe side, we're going to request the compiler to do it explicitly. Again, the compiler doesn't need to listen to us. This is just a request. The compiler might listen to you, but mostly in this case it will. So it's going to be an absolute difference function.
I don't think the compiler will listen to you right now, like because you did request.
Sorry, like, your audio cut out again. Could you say that again?
I say I don't think it really matters right now because you tell the compiler to do whatever you need to make this as fast as possible.
Yeah, exactly.
So I don't think it will take your request at all.
Well, I don't know. Maybe my request actually turns out to be valid, and the compiler's like, yeah, we should do that. But
for such a simple function, it's not even worth like making a function call.
Exactly, which is why it should be inlined. So now we actually have to index the images properly. This is the part where things can go wrong. So we have to do, I believe, and Omer, correct me if I'm wrong, we take the row, multiply it by the width, and then add the column.
Good job.
Did I get it right?
No, you got it right.
Good. Okay, so we're going to get the old and the new, and we're going to do error plus equals absolute difference between A and B. And then all we need to do is say error divide equals the number of pixels that we actually calculated. If the error is lower than the lowest error, then the lowest error is equal to the error, and the lowest error delta is equal to the delta. So that way we find the one with the lowest error. All right, that's the heart of the program, quite literally.
Maybe on initialize. Just set that to
How is that on initialize?
lowest error data. Wait, which one? Oh, and what?
Plus crop width. Okay, never mind. It's interesting that you can actually do that and see it doesn't throw an error. You can just use a variable within its own initialization. Swift would have not let me compile that. Of course, there's going to be this little warning because this is maybe uninitialized, but I know for a fact that it will initialize after this. So
Can we just make it to 0?
okay,
Like,
if we don't want any warnings, sure, or even -1. Okay, so there we go, warning free, and I believe this should work. But the way to make sure it works is to actually try it out. So here's what I'm thinking we do. We manually load in frame 1 and frame 2
and find the difference.
And find the difference and see if it makes sense.
Yeah,
So,
the delta should be maybe like 100 for the first one.
Really?
If I recall.
Let's see.
This one should be exactly 0.
No,
If this is not, if this is not 0, we messed up.
Okay, yeah, let's actually see if it's 0, and then we'll try out the other stuff.
Yeah, sure, we can hard code
Wait,
the height.
the width is 1280, height is 720, and let's just say we want an 8 crop width. Hopefully it gives us 0. What?
We literally took the exact same image, and the delta is 480.
That doesn't make sense.
You messed up.
Did I?
Yeah,
Maybe my first logic was correct before I overthought this.
yeah, no, so let me send you the very first logic that we created for this.
No, it's still 480.
And let's just double check, because it's the exact same like function implementation. This is why I was checking. I'm like, the height doesn't really match. So I sent you the logic. It's about the same. It just only one slight difference.
Oh.
But for this one, it shouldn't matter.
I forgot to take these two into account. But yeah, no, this is definitely not this don't worry, I got it.
Yeah, this is what I was confused when you didn't do.
Yeah. Okay.
Sure,
Now we should be good to go. There we go, it's 0. That's nice, that's nice. Now if we feed in the second image.
94. It should be fine. Let me test that on mine as well.
Sure, you test out yours, and let's actually just take a look at the two images. I mean, maybe we can actually see the 94 pixels.
Because I'm very curious, because it should actually be the same.
Yeah, that should be approximately 94. That makes intuitive sense. I mean, what we could do is we can actually load these up in Python and tile them with 94 offset. Do you want to try that?
Sure.
Okay.
I'm
Because
just running mine quickly.
We have time today.
Yeah.
So I'm going to open up my terminal, of course.
Because just for everyone on the live stream, we're not gonna implement this all again in Golang.
Yeah.
We already have most of this implemented. It's just a clone of what we just wrote in Swift and C. Just direct copy mostly.
Okay, so I'm gonna quickly open.
I'm getting 332.
Wait, what?
So I don't. Oh, yeah, no, mine's different than yours.
Yeah, yours is not the delta; it's the offset.
No.
Oh no.
My first picture is different than yours. So I have a different start.
I see. Okay, yeah, that makes sense then. Of course, it wouldn't be the same.
Yeah, because we're not using the exact same file, like image. Can you send me down on Slack so I have the exact same image?
One sec. I just need to do something really quick.
Okay.
720 plus 94, 814, 1283. Okay. So what I've done is I've created a new array with height 814, which will contain both the original image and the next image that we want to tile on top of it. If we can tile the two with an offset or a delta of 94 and then show it on screen and it looks good, we're good to go, and we can continue with the next piece of logic. Yeah, you want the image, I can send that to you.
The video.
Oh, the video.
Yeah, so we work with the exact same video.
Sure. Okay, it's uploading for you.
Thank you.
So back to our frame logic. So if we import file 1 and file 2, we have the correct logic. Now what I can do is I can just set the first one immediately. Just make sure that we actually have something. Yep. Now new was it 92 or 94? 94. 94 onwards until the end. Let's just get the shape. Good, 720, that's nice. Set that to frame 2. Then image.fromArray the new image and show that. Does it look nice? Good, it's stitched properly. Okay, so the offset calculation is working. And here's what's really, really, really fun. See how the watermark moved down and we don't have two watermarks? That's because we stitched the second image on top of the first one. So the watermark of the first one is behind the second image. And so if we just keep doing this all the way down, we won't have any watermarks. Before, in a previous iteration, we would actually start from the bottom and go on top. And because of that, we had this watermark repeated like infinitely. It was just a black strip on the left of the screen. But luckily now that doesn't happen.
Hey, you know what's actually good about that? We can see the delta.
Yeah, yeah, exactly. But there we go, it worked.
Good.
So that means our offset calculation is definitely on the right track. What I also want to do is quickly time how long the offset calculation takes. So, since...
Also timing. I didn't receive the video either.
There.
These percent.
I did not.
That would have done a good job.
Okay, so I just want to quickly time this and see how fast Clang got our algorithm to run. Not bad. So
How fast?
9 milliseconds.
Oh, that's good. Put two frames.
So then if we were to expand upon that, so we have the 9 milliseconds, and if we're doing that for 150 frames, that's approximately 1.3 seconds. I'm sure we can get this to be faster. I think if I pre-calculate the pointer addresses, that will also help us. So if I do that, we'll probably shave off at least a millisecond. Okay, yeah, 2 milliseconds shaved, so now we're at 7.4, so 7.43 times 150, looking at 1.1 seconds now. So, a little better at least. So, one of the extra reasons this is taking longer than the previous implementation is because we're looking for more offsets.
Okay, so I ran into the same like algorithm in Golang. We got 94 as well, so we're using the exact same image.
Good.
So
Good.
when we do the comparison.
Good. Okay, so we have a pretty fast scroll delta calculator. which is a good thing because we want this to be as fast as possible. Now, FFmpeg is a little bit of a bottleneck, but again, as we mentioned towards the beginning, trying to re-implement an established piece of software like FFmpeg is not a wise decision. So
I did that yesterday.
we did try, but definitely not something that we want to depend on.
So this is actually the funny thing. I used a Golang binding to it.
Mm-hmm.
It was not as fast. I don't know why. It's using the exact same library, but I don't have access to. No, but I didn't have access to tell it to use multithread to do the render and all that. So it's like, oh, it's only using one core for everything.
Well, I wonder why. Okay, so now we can append.
How fast are you at right now when you're doing the comparison of the two images?
7.4 milliseconds.
7.4?
Yeah.
Okay, be a little bit faster.
I mean, of course.
I'm at 700 milliseconds.
700
per
milliseconds?
For the whole set.
Oh, so you're faster.
No, I'm not. This was 100 and 200 images?
Well, 115, so you're at 6 milliseconds. What?
Am I? What? I'm 765 at the moment. But there's so many duplications I ran into, so I don't know why.
Wait, no, you're at 4 seconds. That's 4,000 milliseconds. Not 700.
No. Let me send you my latest one with your. So the thing is, for everyone on the screen, so when I wrote this in Golang, I was timing every single component. So I just keep track of how long each of them takes.
So 1 sec.
So.
Sorry, 1 second. Are you at 765 milliseconds per call or total?
Total.
That is faster than C. What?
Wow, I am doing multi-thread. Keep that in mind. Like multi-core.
You're not doing multi-core operations.
I am.
Oh, you are?
Definitely. Come on, man. This is Golang.
Then at that point, you're basically saying that I got to do that in Swift now.
We don't have time for that. It's 11.
I feel like we will. We'll see.
We'll see. Let's just stitch everything together.
Yeah. Okay. So just load in.
So you're telling me this whole time when we're comparing how fast you're doing everything, you're using like a whole different video set than I am. I was getting like a 1 second, 2 seconds each, and we were like, I was so slow on it. But it was because of the video size.
Yep. But now we're on the same video, so that's what matters.
Okay.
So we have all our different frames. Now it's really just a matter of calculating the deltas. So they're 32-bit integers because they're coming back from C. So I can do for I in 1 ... less than frames dot count. Old is frames I minus 1 dot pointer and new as well. And then I can just do calculate scroll delta old new width. Let's just hard code this for now. Hard code deltas dot append. Okay, that looks good to me. I'm just gonna print out I so we have an idea of progress, and I'm gonna print out I here too. Okay, so that's done. We have the deltas. Now we just need to stitch our images. Isn't that fun?
That's easy.
That is easy, but the only thing is, though, that I can't subscript NumPy arrays with slices in Swift.
Oh.
How do we get a slice in Swift? I didn't even think about that.
Oh. You cannot?
I'm sure I can, but figuring out the syntax for that is going to be
So here's the thing. When I
challenge.
was doing actually doing the binding to FFP, whatever it's called, the binary.
Mm-hmm.
What happened is, since everything is being done in C,
Yeah.
what I did is I just copied the whole chunk back into Golang, and then use it at that moment. Can we not do something similar here? Because right now everything is in C. Can we not just copy that location back into like some type in Swift and then do it from there? Because can you not set, because I'm pretty sure in Swift you can set arrays to something else, like a slice of it. Or is that not possible?
So look, there's a problem here, and the problem is the Python interoperability. In Swift you can do it, in Python you can do it, but the Swift to Python bridge for slicing isn't there.
That's fine, but can you not copy it directly? Like the
Like
whole
copy it
like,
into Swift and then do it and then copy it back to Python?
why do we need to copy into Python?
Sorry, say that again?
Why do we need to copy it back into Python? Is this to save it as an image?
Yeah.
Can we not do that in Swift?
I'm not gonna work with AV Foundation today.
Okay.
But it's
Can
fine.
we-
Memory copies are fast enough. And plus I have an idea, okay? You gave me an idea, Omer. You gave me an idea.
Can we not do this in C?
We're doing this in C.
Come on, man. I swear, the more you talk about Swift, the more I dislike it.
Why?
You slowly got me to the dot side when it comes to Swift, okay? I was liking it, but now it's just, why do you
Okay.
have to do this to me?
We're not even doing Swift right now. We're doing Swift Python interoperability. You don't like the interoperability, but you like Swift.
Anything except for I/O. I
Okay.
like Swift.
Fine. I can agree on that. We've reached middle ground.
I do like the syntax a little bit better once I get more familiar with it. Like,
That's what I'm talking about.
when I
Elements.
first look at it, it was garbage, but now it makes sense.
Yeah. Swift syntax is elegant once you get used to it. Unlike Go. Anyhow.
Go is more easy to read.
I
so
highly
find that.
disagree. Just one sec. How does that make more sense than this? Or even
It doesn't.
these two are valid
It
Swift.
doesn't. It doesn't.
It doesn't. That's what I'm saying.
It doesn't.
How do you know
Okay.
what the key is and how do you know what the value is here?
Well, technically, it does make sense because you know the key is gonna be a string and the value is the int. It's just because you're so used, like in most languages, you're so used to saying string colon something, especially in JSON or YAML. Sorry, yeah, even YAML. That we just thought that's the assumption. I really do like the way that like Python or even Swift did, like Python 3.6, that when you want to initialize the list, you put
Sorry,
bracket and then
Your audio kind of cut out in the middle, but yeah.
yeah. So the thing I
Uh,
do like better.
Yeah, good now.
The thing I like about Swift and even Python,
Come
like
on.
3.6, that you can define array just by the bracket, and then inside of that you can do the type. That
Wait,
make more
you
sense.
like that about Swift?
And also Go.
Okay.
Not Go. Like I mean Python 3.6.
Oh, okay. Yeah.
I know.
Yeah.
It just makes more sense. Okay, I came from Java. I was so used to having the bracket before or after, but like I still like the other way better.
Yeah.
I guess it's just preference.
Mm-hmm. So I'm just wondering.
Seuss is like Go is made for Googler with huge bread for coming for C.
Beard.
Yeah. C, no, Go is very C-like, I have to say, which I do like.
Mm-hmm. The only thing I really cannot get around about with Go is that the type system is so complex.
How so?
Like in Swift, if I have an array,
Mm-hmm.
a dictionary, a set, they all just conform to one collection type. And if I wanted to add a single function to every collection that exists, I can say extension collection, and now all these collections have another function.
So Golang is not really built like that.
That's what I'm saying.
I wish it was. No, but I'm hoping maybe in version 2 or version 3 or whenever it'll come, you can actually extend current types. Because at the moment you cannot. You have to just like make another type with it.
Oh. Okay.
Kind of useless, but whatever.
Okay. So this copy images function is going to take a double pointer to all the different images that we've got. Then we're going to pass it the new image that we want to process. Then we're going to pass it the array of the deltas. Finally, we're going to pass it how many images there are in the array. Because, of course, within C, we're using pointers, not arrays, and so we don't know the count until we pass it as
Wait,
a
wait,
single
wait. So
parameter.
we're gonna pass it all the images,
Yeah.
and then we're gonna pass it the new image to add to it. What do
Yeah.
you mean by that?
What do you not get about that?
So
So
we're
we
gonna
have the new
stitch-
image. We have the final image, which is really, really long, and we have all the
Which
other
is
images
new
in the
image?
deltas. Yeah. And then we copy from images into the new image.
Oh, okay.
Yep.
Okay, got it.
Great.
I was thinking something else.
Oh, no. Well, yeah. So what we want
Might
to
have
do
been the
now is basically the first image is going to be copied from the current ceiling point, which is what I'm going to call it, until the current ceiling point plus the next delta. At the end, because there's no next delta, we say copy until the end, and then you're done. In the beginning, we're assuming that you're not scrolling up because that would be impossible, right? You cannot scroll up from a ceiling.
It does happen. It did happen. That was one of the edge cases.
Why?
I have no idea. The very first delta was minus 200, and I was hitting that issue in Python. I'm like, oh, this doesn't make sense.
Could they not have made it a little bit simpler? Anyway, let's assume we don't have that edge case today.
No, okay. I already solved that edge case issue anyways.
Okay, then if we can solve it with this new implementation, we'll solve it too, but for now, ignore it. One more reason this is a little bit more complex is because all these pointers are now RGB, so we have to copy all three values. But it shouldn't be too hard. Actually, no, it will probably be a little bit more hard, because now we have to do 3D indexing. Omer, you're going to be in charge of figuring out 1D or 3D to 1D indexes, alright?
3D to 1D?
Yeah.
Why?
Because we have art like white width, height. No, sorry, height, width, channels.
Height, width, and then 3 channels.
Yes.
Red
So that's
RGB
3
is right
dimensions.
after it.
That's 3 dimensions.
Wait, I thought everything is just 1D in the end of the day.
Sorry?
So do not tell me the way that Python storage is all the red, all the blue, and all the greens after each other?
No. It's RGB, 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 RGB.
Yeah, so we only need to do 2 dimensions.
Yeah, and then we can just do offset by 1 and 2.
Yeah.
Okay,
I
sure.
can show you the algorithm for that.
Sure, that should be simple. I was just wondering, because it's 3D, we might need to do extra offset for like
No,
things.
no,
Okay,
please don't.
that's fine.
Please do
If
not
we
do
don't
that.
need to do that, then that's fine.
You're making this worse.
Okay, but still, you're in charge of that, so I leave that to you.
Also, why do we... No, this is a very simple thing. We just find the offset. Whatever the offset is, time that by 3. You get the next location.
Okay. Just on the live stream, let me know if Omer's audio is clear. If it isn't, let me know, and then we can fix that. But for now, we'll keep going on. So,
One second, let me just use my laptop audio. Hopefully that doesn't echo too much.
Okay.
Once, I guess no one can hear me yet.
I can hear you.
Oh, okay, I can hear you.
Good. So delta index 0, delta index less than the image length, delta index plus plus. So we want to sort of just instantly copy the first one, and the way we're going to do that is by figuring out int header length equals basically just delta's 0. And then, actually no, we can even set that to current ceiling. Or does that make sense?
Oh, it should be fine. The current ceiling should be the very first one. I'm just looking at the way that we did in Python, which is the very first one.
Yeah.
Current ceiling is 0 actually for us.
Sorry?
We set it to 0.
Yeah, we set it to 0, but this is a little bit of a different way that we're doing it.
Okay.
So I'm thinking we create a separate function for the actual copying mechanism. So the way that I would do that, let's just request the compiler to inline this. And copy image. And we'll take from and to, and then start index, start row, actually. In height. And then...
I'm very interested to look into how Golang does slices, because you can just set slices to other slices. I wonder how the backend will look for that.
Wait,
does it just do a copy? No, so do you know in Python you can set slices to slices? You take a slice and you set that to another slice?
Yeah.
Golang can do the same thing. If not, forget about it. But I want to see how I actually handle it in the backend. Like, is it actually copying it, or it does reference, which is going to be very interesting because the performance on that. Because the whole point of an array is that you know the offset, which is a known number, and you get the index, time that by the offset, and you get the exact location in memory.
That would be interesting to take a look at, actually. Well, for now, we're doing it ourselves. So, let's get back to coding. So,
Zeus is like great audio. Yo, everyone can hear your keyboard. It's fine. You know that this is actually live and not pre-recorded.
Yeah. Okay, so we have to figure out the rows. So row equals start x, row less than start x plus height, row plus plus is how we're going to implement that. And then what we're going to do is say from row times width, and just...
Do you mean start y?
What?
Why are we doing start x?
Why? Sorry. I got confused with my dimensions here.
Yes, I was confused too.
Okay. Row times width plus call, and then we can do for call equals 0, call less than image width, call plus plus 2 row actually no, this is supposed to be 2, and then we want to set this, but how do we know what the I feel like we could just do row minus start y from row minus start y times width plus call, and then for int RGB equals 0, RGB less than 3, RGB plus plus.
I kind of think I kind of give Python a little bit credit when it comes to how easy it is to code, because you can do so much like stupid stuff in it.
Yeah.
Because it's slice assignment.
Yeah, exactly. Like this in C is like, we have like loops in loops in loops in loops.
And Python is one line.
Yeah, exactly. You don't even think about it. It's just hand it over. So I was gonna look for 3D index.
No, it's not 3D. It's not 3D.
No, it is 3D. It's
No.
height width channels, man.
It's offset, is it not?
It's not. I can pretty much guarantee it.
No, but you say it's all GB, all GB, guarantee it. No, but you say it's all GB, all GB, all GB, back to
Yes.
back.
But like, look, let's just say we want to go to a certain 2D index. You have to remember that all the other GBs after the R have made it so that there's an extra offset for going to a single element, so to a single R.
Go back, I'll tell you the math.
Tell me.
So find the offset. So the offset is gonna be
So this
that.
is the, so we want to do, so in Python, what we want to do is to row call RGB. That's what we would do in Python. How do we do that in C?
Are you kidding me? It's like that?
Yes.
Okay, can you go on to the next line? But
like this is like
index
basically
zero
in
should be
Python. Wait,
RGB.
one sec. In Python, we would be doing this.
Yes.
So how do we
But
get
okay, press next line.
those three
Go to the next
indices
line.
converted to a 1 and 1D?
Yeah, go to the next line. The format is gonna be RGB for index 1. The next index is gonna be RGB, and so on, right?
What?
RGB, RGB, RGB. Can you just type that in?
Just RGB? What?
And then RGB. Just keep doing it 3 times. Yeah. So if we say we want to go to row 0, 0 and say 1, we should get the first G, right? Yes or no?
So if we're doing row 0, column 0, RGB 0, then we would get R.
Yes. And then if you do 1, then you get the G. If you do 2, you get the B, right?
Yes.
Yes. So what you need to do is first compute the offset, which is row times width plus column.
But that offset is
Times
offset.
3. Times 3.
Okay. That I can get behind.
No,
yeah, like,
please put that in
yeah,
context.
I got it, but yeah. Okay, that makes sense to me.
But do keep in mind that this is only gonna get you the R. You need to get the rest.
Yeah,
So
that's totally fine.
compute this once, and then you just plus 1, plus 1, plus 1 constantly.
Yeah, plus RGB.
I mean plus 1 and plus 2.
There we go.
Where's RGB coming from?
This loop.
Well, sure, we pre-computed everything. Like we computed so much.
What I could do
The
is,
compiler would take care of this.
I mean, yes, but I can tell it unroll 3.
That doesn't do anything.
Yes, it
You still
does.
have to no, but you still have to do row time image width plus column, unless the compiler shuffle that up.
Oh yeah, no, totally. The compiler will definitely put that into a single computation. No doubt about
Okay.
it.
I don't trust the compiler sometimes.
I trust the compiler with my life here.
Okay.
At least Clang. I'm not sure about GCC, but I trust Clang.
Okay, let's go.
Okay. So let's go ahead and just try putting the first image in and see if the copy image logic even works. If it does, I'll be very surprised, honestly, but I'll be happy. And if it does, good for us.
If it doesn't, time to go to Golang.
Okay, so what were we gonna do here? Copy image. How will we do that exactly? Let's create a new image, which will just be an NumPy zeros. I just want to make sure I'm on do not disturb. Okay, yep, I am. Okay, so we want zeros.
So we know the total height will be the first height plus all the deltas added together. So that will be the maximum height.
1 sec. I just need to quickly put this in as type uint 8 and then c type, and then I have to keep that around, and then I can do let pointer new image c types data, and then do address to pointer.
Why do we have to do this?
I do not want to, but that's what Swift makes us do. I'm sure there's a better way to do it, but I just don't know how.
Well, we are going between 3 languages, so
Yeah. So then if we copy, oh, I forgot to expose it in my header. Okay, so then we can do copy image from frames 0 to new image. Start Y0, and I only want you to copy 100 pixels, width being 1280. Then if we do image.fromArray new image.show, then we should get the first 100 pixels. Okay. Let's see what we get.
You know the one thing I do like about it? The dot show, because it's not easy to do that in Golang.
Sorry, what's not easy to do in Golang?
You just show the image on the screen. Unless you guys, I think there might be a package that does that, but
oh
Python,
yeah. Well, this is
like that's
Python. Yeah. In Python, that's trivial.
in Swift, that's a lot of work. You import Python.
What?
What's going on?
Oh.
Okay.
I think that's because. No, that should work. What? Oh, I was passing it the image instead of the pointer. I really hope this works. It's showing us an image. What is it showing us? Oh my god, it worked. What?
Okay, so so let's copy the first 100.
Yeah, the first 400.
Let's copy the whole height. I mean, sorry, copy the
whole
the height is.
720.
Yeah.
Wow,
And then let's do
that
the
actually worked.
I'm actually shocked.
So am I, actually. Wow.
Okay, let's stitch the first two images together and
I'm a
see what
lot
happens.
happier about this than I should be, but that's good. Okay, so
So we need the
back to
first
code.
call. Yeah, so we need the first copy no matter what, because we have to copy the very first image into it.
Well, 1 second.
Zero. Height. No. Why do we want to do that?
There's a reason.
Okay. I do need to implement this in Golang, so whatever you do, I need to copy.
Okay. Well, it doesn't need to be exactly the same, but so the reason we do that is because, remember, after that value, it's going to be replaced by the second image anyway, so we only need to copy those many values. So the first one just gets copied regardless. Okay, so I don't care about anything further from there, but the first one must be copied. Now from there, what we end up doing is offsetting.
If delta is less than 0, you have to do a special case for that, just to let you know.
Yeah, and we're not doing that right now.
Okay, yeah. It's not going to be in this video. I don't think this one will hit it as well. We will see.
This video does not go negative first. This is a more civilized video.
Civilized.
Okay, so
When is YouTube ever civilized?
so we have the delta value, which we then say, let's just do this the naive way and not the optimized way, where we copy a lot of extra information even though we don't really need it.
Yeah, that's fine.
Never mind.
So I'm guessing the lesson of the video is going to be never try this in Swift.
Don't say that.
You know the funny thing is, you could in theory do all this in Bash as well, which is the sad thing.
Let's not. Let's just not. Just don't.
It is sad. No, but the main component is probably the delta and also the FFmpeg, I think that's what it's called, the program, the binary. And that's it. And the funny thing, we just can't command line for that.
1 sec, I just need to... Okay.
In the meantime,
So
I'm gonna set up the Golang environment on
Yep.
on my side because you should be done soon.
definitely.
Oh, I also found something interesting. So I remember the last video we did, we talking about why, like which laptop to use for programming.
Yep.
So one of my friend, what happened is they're using a Windows machine
Mhm.
and they have the subsystem Linux. So when we run a program and I open up a port, for some reason when that program ends, it doesn't release it from the Windows side.
Sorry,
So
quite a bit of your voice is
oh, chop. So what happened is you're using the Windows subsystem. Good.
now it's okay.
Okay. So you're using this Windows subsystem to launch a program that open a port and like a website.
Yeah.
For some reason, Windows doesn't release it when the Linux stop, like the program in Linux stop.
Oh.
So it's just like an endless process of it, just a long wait. So I have to actually find a program, process killer, that just go and kill that process, because when you try to kill it with using kill task,
Yeah.
you get access denied. Even through your admin. Like what happened, I opened a terminal as admin and it still denied me. I'm like, wait, what?
Interesting.
I'm supposed to be admin. Why am I getting denied? So another point is don't use the sub Linux system on Windows.
Yep.
It's not the greatest.
Yep. But they've made some pretty good improvements, I must say.
Yeah, it's better. I'm just hoping to have a proper dash interface on Windows, not like you have to use third parties.
Yeah, I really do not like the
Get something
Windows
remote.
command prompt. Luckily, with Windows subsystem for Linux, at least we have a decent terminal.
You know, for live ergonomy, I cannot actually use Linux like the Windows terminal at all now, because I'm
Omer,
so used to Linux.
can you do me a
Yeah.
favor? Can you speak a little bit to the advantages of the PowerPC architecture?
Why?
We're getting a question if I'm excited about the future of ARM for consumer cloud, and I am. And the comment is, I guess x86 will be another PowerPC in the future, but I feel like PowerPC is still really useful for some certain tasks. Can you talk about that?
Yeah. So like a good example is power itself doesn't use too much of it doesn't use too much power wattage, so you can have more higher core counts. And I don't want to sell like any like specific software or anything, but certain software require a lot of codes to do a lot of optimization and process data faster. So especially like databases. So again, since I work at IBM, we have a database called DB2. It sounds like I'm selling it now. I'm not. What happened is that there's a lot of routes inside of there that is heavily optimized for power, and they can actually use those additional codes to perform stuff in parallel. And another use case is, let's go back last week when we implement the hashing algorithm.
Mm-hmm.
Even though my Mac is faster, like for core, the power system so outperformed because there's so many more threads, and certain tasks just require thread count, nothing else. And someone mentioned ZOS. Yeah, I'm not getting into that piece. But one thing that if you guys do want to look into it is when you get into Docker or just microservices, ZOS is very efficient at that. Believe someone, I'm not sure if this is released yet or not. There was a comment that someone told me about that they can release they can spin up thousands of containers, and it doesn't even touch the CPU at all in Linux on ZOS. I'm not sure if you're familiar with that, Tammy.
Me, I have not used ZOS before. Well, I mean,
It's
I've
very
used it
efficient
before, but
Yeah, I know it's heavily efficient when it comes to containers. I don't know what they did with it. I haven't really looked into in depth for it, but there's a lot of work around that.
mm-hmm.
The only sad thing is it costs so much money to even do anything with Z because of the hardware. It's a lot of money.
Are the Z and Power architectures related in any way?
I don't think so. Z, like the thing is, one CPU on Z Linux is way more powerful than one CPU on like x86 or anything. What happened is when we were doing a microservice architect on Z Linux back in like 2 years ago, what we found is that we cannot even request the same a number of resource. So in Kubernetes, I'm not sure if people are familiar with it, you can specify how much CPU you need. So it could be like a point, like extension of the CPU, so 0.5 percentage or whatever. What ended up happening is that if you request the exact same amount in Z Linux, it doesn't actually match because the power is like 2x or even more. But the issue is that Z Linux is very expensive and each of the CPU is very costly. But the whole point of it is just to be high performance, which is why a lot of mainframes are using it. I think Z Linux is just a mainframe operating system. I don't think anyone else really uses it for anything else. Unless you can correct me or someone in the comments can correct me.
One sec, I'm dealing with Swift being a little annoying. I'm doing a very bad thing, but...
Someone did mention back then when Apple switched from Power to x86, it was behind in performance per wattage according to his graph.
ZOS is made by IBM.
Which one?
ZOS?
No, used by.
Oh, used by Swiss Bank, yeah.
ZOS is probably, I don't know if you guys know about this or anything. A lot of the mainframes, so like credit card transaction, or even any transaction specifically, especially in the backend, is usually done by IBM and is most likely a Z Linux in the backend that handling it. They're just very highly efficient and very tolerant when it comes to power and stuff like that.
Yeah.
So I saw this video. It was one person that taking care of a Z Linux system, and it's like a huge container, like a huge setup for it. Surprisingly, how much work going to that is shocking. Because everyone's just used to just like a laptop or just a desktop with like a little bit of hardware inside of it. These systems, you have like multiple CPUs, multiple power supplies. There's one system, they have 2 power supplies directly into it. I was really shocked.
Yeah.
Okay, let me get on the
Okay. Wait. No. There we go. Okay. Let's try that out.
Okay.
So we're currently not actually rendering any results, but we're just... Oh, there we go. It crashed. Simultaneous access, but modification requires exclusive access.
Wait, what? You're not doing anything multi-threaded. How?
What?
Wait, what? Is something using while you...
That's not possible. No, there's only one thread here.
Wait, what?
See, there's only one thread.
Yeah, no. So how is something being blocked? But modify require exclusively access. What?
Excuse me?
Wait, what? What's going on here?
Can we look at the actual assembly? Like, what is it trying to access that causes that issue?
Can we print out every stop, like...
Okay, so deltas has nothing in it for some reason.
Which should not... Okay, can we print out delta and see what that is? Oh, yeah, I forgot. You have a debugger right now.
There should be values in deltas. Let's put a breakpoint here.
Yes. Something that is very useful. Encoding. Wait, what?
Okay, that's good.
Oh, okay. Okay, can we just skip 54 completely?
Okay, so deltas looks like it has 114 values, which is what we need. Okay, they're all zeros. Oh.
Wait, no, incorrect.
What?
Oh, okay, never mind. You starting from 1. I'm so used to starting from 0.
Okay, so now the deltas are all 282.
That's incorrect.
which is incorrect. Wait, what?
But we know the first one was like.
Am I passing it like the width and height interchanged? One sec. I need to pass it width, height,
Width?
crop width, which is correct.
Yeah.
What?
We did the first image, did we not?
Yeah, the first image worked.
Can we just talk about the first calculation and see what happened?
Okay. Or even actually show the images. Is the garbage collector still getting to them somehow, maybe?
Let's do this. Actually, no, it's really hard to debug this now.
What I could do is just to be on the safe side, even though this will do nothing.
Are you gonna stop it from garbage collector? No way, you can do that? Thanks in Python?
What?
You can disable it?
Yeah. I'm not sure how. Okay, so it's still 282. Maybe it actually is 282 somehow. Let's actually show the images. One sec. Image dot from array dot show image dot from array, and actually do array.
So someone mentioned, is this Python code?
Oh wait, I have to convert to Grayscale. I forgot to do that. Yeah, that would do it.
Yeah, that would do it. But still, why is it? I will assume it will still work.
No, it won't. There we go.
Okay, there we go. 94, 94, 94. Wow, that's a lot of 94s.
Yeah, it happens sometimes. Does 44 suddenly scroll up like a lot?
Let's go open that form. No, I'm telling you, one of these are very messed up.
Oh yeah, wow, that was
Wow.
that was a big scroll.
Yeah, wow, that's a big jump.
That's a big scroll.
And this is just unique images too, so the duplications should not be there. So in the video, it actually does the jump this fast.
I feel like this might cause us an issue.
Oh, it's fine.
Yeah, you're right. It should be fine actually.
Let's stitch it together because we know for a fact that this should stitch all together, this image.
Okay, let's
we?
just stitch it all together.
Can we show the final image?
Yeah, that's what we're gonna do now if it doesn't crash here.
But like, oh yeah, sure.
Yeah, see that crashed.
Again?
Simultaneous access. A previous access occurred in main. Current access or read started at. Oh.
Are you kidding me? No.
Okay.
No.
If I know the Swift compiler right, this should fix it.
If this is the issue, why does Swift have to be that sensitive?
Yes, it worked.
Right?
That was the issue.
No, but how is that? How is that an issue?
Swift is an enigma.
Sure.
All right, let's try this out. Now, if we've done everything just right, we should see a final stitched image.
Which is not going to be the case because for some reason we didn't increase it.
Because we only gave it 720 height.
Oh, sorry.
Okay. So we're just getting the sum of the deltas.
See, this is what I mean. This is black magic.
Come on. Null pointers now?
But where? What? Was it not working before?
It was.
Oh. what is the height that we're passing it to? Can we print out?
One sec. If we go back into copy images with deltas, the current delta index, does it even have? Yeah, 105. That should not be an issue.
105.
That should exist. That absolutely should exist. Images.
You can't go into point memory like that.
Yeah.
105 is not the last one either. So
Wait, why is new image also null?
wait. Let me see. This looks like.
This was supposed to work.
Raw time image width. Raw minus start y. Why start y like that?
Because
Okay,
remember,
never
from needs to
Yeah.
start at the beginning.
Can we do the first like 20?
Only
Let's
the
stitch
first
just-
20?
Yeah, let's just stitch 20.
Okay.
So just change it so we're only gonna get 20.
Okay.
I think we bite in too much at once. We should have done slow.
Okay, that...
Oh,
Oh, it worked. It actually worked pretty nicely. Oh, it actually stitched them together. That was surprising. But even though it stitched them together, why doesn't it work when we increase? Let's just say we go up to like 60.
No, what was it? 105?
It was 105. I know, but like I just want to quickly see if it
You know
continues
this
to
will
stitch properly. I know this will work, but okay, I just want to see the final result. Yeah, that's what I was afraid of.
What's going on? Okay, let me print out all my deltas. You print out all your deltas, and let's just compare quickly.
Sure.
I will send you my deltas. It'll just be like 11 seconds. Okay, fine, I'll do that. I do have a negative number here, actually.
Yeah.
Negative 240.
But at like what index? Send me your results.
Yeah.
Okay, so your results and my results, let's compare them in Python, of course. Seriously, there's spaces, not commas?
No, I'm printing out directly. Come on, man.
Still, it should insert commas for you.
I wish it was that easy.
Go just violates so many intuitive standards.
You should print out. You should try printing out what is it called?
A map?
Not even a map, just a structure. It's just a mess.
Yeah, I've tried before and it's pretty terrible.
How does Swift handle it when you print out a structure?
It prints out like the parameter name, colon, and then the value, and then comma, and it does that like in a regular way.
I wish Golang just convert everything into like a JSON and print that out, but it's Golang.
Just want to make sure I slice this properly. Yeah, good. Okay, so here's what I'm thinking we do.
Why do we compare only to 59? Oh,
Because I'm only calculating until 59, and just let's see what the result is like.
of course.
Okay, so it looks like both of the lines are either the exact same or we only ended up plotting one.
Wait, what do you mean?
Wait.
Wait, what?
Okay, so we're plotting one line. Now we're plotting another line, and now if we show... Okay, yeah, they look to be the exact same. And a good way to check that would be...
But we know the first, oh yeah, no, first 60 frame was messed up for you.
Okay, so yeah, we do have some issues. It
The
looks like
difference?
wherever there's a negative, it's an issue. Or no, that's not it.
So this is the difference between mine and yours, right?
Yeah.
So we are computing the exact same images. That's not an issue.
I'm just trying to
You
make
want to just
sure
do this in
that-
Golang and see how it works?
Yeah, that's what I'm thinking we do. I just quickly want to take a look at something before we switch over, though.
Zeus is like, Omer will never touch Swift again. Since I knew Tammy about over, was it a year and a half now or a year? Well, how long it is? You're always trying to convince me into Swift, but for some reason I convinced him to Golang. So I won. And the one thing that I found out is what happened is we were trying to read this file in whatever language we want to use, and it was just a binary file. We found out that for some reason Swift is just it's bad at I/O for some reason, which doesn't make sense.
You're right. I don't know why Swift is so bad at I/O.
But the thing is, you import C to read I/O, which is faster than the built-in one, which doesn't make sense. I was assuming the built-in one is optimized.
I don't know. Okay, I am so confused. I'm just trying to wrap my head around exactly what's going on here. Let's just say we take which delta is the one that's messing us up. If we do this dot index -15, it's 27, so that would be index
So can we
28.
do up to 27?
So that means that this image over here is messing us up. So these two somehow.
Your image or mine image? Or like my output or your output?
My output is wrong.
So this should only be maybe 100 delta.
Okay, so 27, 28. Let's actually import those manually and see what
The
that
deltas?
delta looks like.
Okay, so 27, 28. Let me
Yep.
print out my. I actually already know my delta for that.
Well, can you find it, please? Between 27, 28, so index 27.
27 you want?
Yeah.
I'm just gonna print out from 28 onwards. Okay, so from 27 onwards, so 20, 21, 22, 23, 24, 25, 26, 27?
Are you counting
want
it
27?
manually?
20, you want 27, right?
Yeah.
For some reason I'm getting 360.
Okay, let's see what Swift gives me. Oh well, not 27, 27, 28.
Oh, 27 to 28. I'm getting like a big number as well for this.
282.
282 again?
Yep, and Xcode crashed, which...
I'm getting 360.
Okay, so that's an issue.
So let me stitch mine together because I haven't done a stitch yet, so I don't know if it actually worked.
Oh, well, see, that might be an issue.
But what we could do in theory is we can go back to our Python example that we started all this and find what that delta should be.
Yeah, that's what I was thinking we do. Can you do that for me, or do I need to do it?
You want to do it?
Okay.
Because you're showing your screen anyways, right? So you don't have to.
This is the
someone
very
mentioned-
first version ever.
Someone Zood mentioned again, Swift is not meant for console.
Well, that's debatable. I mean, Swift is...
No, it wasn't. It's not really designed for console because whenever the one hackathon we did, and we did it in iOS, it makes sense the way Swift was handling everything. But until I go into iOS development, I don't think I will touch Swift.
Your loss.
My loss is no generic in Golang. Sad.
See, Python is just it's amazing for some things, but terrible for most.
So is this the Golang implementation or is this the
Python.
No. Oh yeah, this is Python.
Unfortunately, my VI does not currently have syntax highlighting with Python. I still have to install that.
I don't have it either. Don't worry.
Okay, so 2728, that's good. Calculating delta, printing it out. Well, let's see what we get. Oh wait, no, this is gonna run FFmpeg. We don't want that. In fact, we don't want anything. We don't want any of this error checking either. You implement very safe code over.
I'm sorry, okay? I just
It's a
like
good
safe
thing.
code. Wait, you not passing anything? Like pass a file at least. No, you gotta pass a file.
I commented that out.
Wait, what?
It takes some time to calculate because we didn't crop it. We're giving it the whole 720 by 1280. Or no, you did. No, you didn't. Wait, maybe you did.
How do you load it?
I just do image.open, convert it to a NumPy array, and get a mean on the axis, and just feed it in. Okay, so the actual value is 94, but for some reason Swift thinks it's, or C thinks it's...
Let me do the comparison again on mine, just to make it more, like, reasonable, because I might miscalculate it.
Sure.
So you want, which index do you want again? You want 26, actually, for me. Because mine delta starts from 0, you want from 27 to 28, which will be... let me just pick up both. Because I do get a lot of 94s.
Still 282, what? Maybe if we increase the crop width, maybe it just needs more data.
I'm doing 20 on mine,
Still
by the way.
282.
Okay, can you go back to the example, like the images? Can you do 27 to 29? I mean 28 to 29? Is
Like,
that a big
in my code?
No, just open up the pictures, I mean.
Oh. 28 to
So in my
29?
implementation, yeah, in my implementation, I have to
Yeah,
constantly
28 to 29 is a huge jump.
Okay, so mine is actually 94. Mine is correct then. It's 94. for
Okay,
mine.
so 27, 28 should just be 94, but then 28 to 29 should be huge.
Yeah, so can we do that also in the calculation in Python?
Sure. So you want to compare...
Because I'm pretty sure my Golang implementation is also correct then, if this is 360.
So 28 to 29.
Yeah. Because I do see a big spike here.
Okay, I'm going to let this compute in the background. And until then, I'll do some other work. So 28 to... Let's just keep this 27, 28. What I'm going to do is I'm actually going to print out the error for every offset.
One slow there.
It shouldn't be too slow. Oops.
So Zeus, I have another question. Have you guys ever tried using getting float?
Sorry, using what?
I'm probably butchering this pronunciation. If you go to the question session,
I can check it in just a sec.
what is this?
It's what we have to do.
What is this monster?
Anyway, but yeah, the result is 375 from Python.
375?
Yeah.
Okay, so I'm very close to that. I'm at 360.
Well, it's still not exactly what we want.
Yes, but it's still pretty accurate.
Okay, what is this?
What is this?
That's what I said. It's
So
spiking up and down. Oh wait, I forgot to convert it to grayscale again, of course. Why do I keep forgetting to convert to grayscale? Okay. Now it's giving us 94, which is what it's supposed to give. But if we do 28 to 29, let's see what that gives us.
I think this is where we're both messing up.
Really? I get 375, which is what Python gives me.
Oh, I'm getting 360.
Okay, so your implementation's kind of messed up. But then why doesn't it stitch properly, though?
I want to try. I haven't done the stitching yet. Let me do it right now then.
So we're calculating the scroll delta, that's all well and good. Let's just try stitching once more, and this time with a higher crop width.
Let me know how it turned out. I'm doing a stitch on my side. Can you send me the...
Still a couple of errors.
There is? Can you send me
I
the...
have a feeling that actually might be a problem with how we copy and not necessarily a problem with the deltas.
Could be. I'm going to just implement the way I did in Golang, in Python, and then from there, test it.
Okay.
Unit 2 is going to be...
This is what I'm going to do. I'm going to take this. We're going to quickly do this in Python instead, so... bin stitcher.py. Import NumPy as np from PIL. Import image. This is going to be some rapid code that we write here. We're going to extend the episode for a little bit, just so I can finish up this little stitcher. But after that, we'll be done. So, def run stitch, new image, old images, or frames, deltas. So how do we do this exactly? I'm going to quickly copy over a little bit of stuff. So if we take new image and we have frames 0, basically just I is equal to 1, for I in deltas, or no, not for I, for delta and deltas. We don't want to redo that. Then we're just basically going to do current seal plus equals delta. If, well, we're not going to deal with that right now, but long image or new image, current seal to current seal plus 720 equals frames I plus equals 1. And then just image dot from array new image dot show. Let's see what happens if we run this. So I'm going to quickly import system and do syspath append users Tanmay backsheet desktop, and then do let stitcher equals python.import, and then I have to get the file name, which is actually stitcher, and then I can probably just do a little Python magic, and I can do stitcher dot oh no, what did I just copy in? run stitch. Okay, good. New image, and then pass it frames.map and get the array for every frame, and then it needs a deltas. So deltas. Okay, let's see what Python has to say about this then. Really, no module named Stitcher. I literally added it to the system path. Do I need to create?
Okay. You know what I realized? I kind of regret doing the copy of the slices. It can be so annoying to handle.
Do you? Really, are we not able to import this Python module? Come on, we've done this before. Do I need to have like an init.py file? I don't know. I don't do Python packages. Let's see. Import py file Python. Oh, if I don't include this, and if I have the init.py file, maybe. Oh, come on. There literally is, though.
What happened?
I cannot seem to import a Python file as a module. Okay, let's just say I go to like downloads. Can I do Python import sys.path import stitch? Really?
So when you look at my implementation, please forgive me.
Will I be able to?
You see, because I'm doing the stitches right now, and you have to cast some stuff around.
Where's site packages? Okay, there we go. How do
So do
these
you know
folks? Yeah.
You know how you only have to deal with RGB?
Yeah.
I have an A to deal with.
Yeah, but I just ignore that because there's never an alpha. I just drop it.
Golang I have to use alpha for some reason.
I just drop it.
I cannot.
What do you mean? Just don't use A?
When you create the thing is Golang by default, when I load the images,
Yeah.
it's actually loaded as a RGB A. So I have to use it as RGB A. I cannot drop it.
Wait, what? That's so weird. Just don't use the variable. Go says you have to use the variable somehow?
No, so what happens when you create the index, you have to set it to 55 because when you save as a PNG, you get the color and alpha is actually used.
Oh my god. Was
Yeah,
Stitcher inside of a different directory? Where did I store Stitcher?
We went over the time limit.
I know, and we'll be ending in a moment, but where did I store that folder?
Maybe next time we do this in Golang.
It was in the home directory. Okay, now
I'm curious.
Does Python deal with this better than Swift does?
Imagine Python does. Nope.
And I forgot. It doesn't want H.
Wait, what?
Don't worry, it'll work.
Why are we doing 720 there?
Because it's the height of the...
The first one?
Yeah.
Okay. So we're truly all using all three languages now.
Okay, there we go. So it was an issue with how we were copying, not with the stitching. Luckily.
Okay.
Which is very relieving to me. Because what that means is that we are actually done. So if I go ahead and change this to frames.count, watch this. This is amazing. We run this, and it should, theoretically, stitch everything together from that video into a single comic image. I will be very happy if this works, and it doesn't, but let's see why.
Oh. Yeah, the last one is not a perfect fit.
What?
Can you just use my logic?
Sure, but one sec.
Yeah, I sent it to you.
Wait, no, I feel like that's a bigger issue that we've uncovered thanks to this, but okay. I'll use your logic.
It is in the same format, so you can use it pretty fast.
Yeah. This is the exact same logic
That you're gonna use?
that I'm already using. It's
No,
just
there's
checking
no-
if current seal is less than 0, which it never will be.
Let's see.
Seriously, I have to re-tab all of this? This is why we don't use Python. Okay. So now I just need to replace H with 720.
Yeah, you can just set H to equal 720.
Well, yeah, I could also do that, but...
If this work, we're done.
Hopefully, but I don't think it solved the issue that we were encountering. Yeah.
Nope.
Oh, real frames is not defined, seriously. It's frames.
So it wasn't the issue. Yeah, let's see.
Well, no, that wasn't the issue. Last time it was an actual issue. This time it was just a variable name.
So what is the lesson for this live stream? Never to use this many different languages?
I feel like... Okay, long image wasn't defined this time.
New image. Well, for everyone that's on the live stream, this is an example why you don't copy and paste blindly someone else's code. I'm surprised it's so taking this long to do. Okay, now we have an issue.
Could not broadcast an input array from shape 720 to 663. So what that tells me is that we're not giving the image enough height. But why though? The deltas should calculate the height for us.
It just add like 1,000 and who cares?
Yeah, at least we'll have a final image. Although then again, this is probably a symptom of a larger issue within the system.
Of the deltas.
Yeah.
So one thing is, since delta can be negatives, especially the last one was a huge negative, that might have messed up some logic.
And I wonder why it's so negative.
Yeah, the last one is
It's probably going to
huge.
appear really warped. Let's see.
Huh?
Okay,
Oh,
let's
go
see.
to the very end.
Yeah, the end is a little messed up, but this all looks good, this all looks good. It's just the end that sort of messes up. I wonder why. Let's see what happens at the end.
Keep going.
Nothing. This is the end. Nothing special happens at the end.
Go before.
Before?
Keep going.
That's it. That's it. It ends. There's no more.
No, keep going back. Okay, that's just so the delta cannot be 700 at the end then.
It cannot be negative 700. Oh wait a sec.
What? There's no way that what is it? Are we doing 8 pixels or 20 pixels right now?
20.
Yeah, there's no way that 20 pixel ride will cause an issue.
Sorry?
But let me see what I'm getting the delta at the very end.
Your voice is gone.
Okay, can you hear me now?
Yes.
Okay, so when I print out my deltas, my last deltas are 94 and 0.
Mine is 94 and negative 715.
Yeah, so your delta is messed up. Maybe the logic.
It's probably the logic. I'm just doing this out of superstition that it might be.
No, but it doesn't make sense. In the
checking
end,
too many offsets. There we go. That makes a lot more sense.
Yeah. Oh yeah. I was gonna mention that we use 1.5.
Nice. Now it works.
Okay. Can we minus the one? Like remove the 1000 at the end?
Wait. Does it cut there? Oh, it cuts here now.
Wait. What?
Maybe, if we convert this to float, right, and then we do float e, or real error, equals float error divided by...
Someone mentioned the stream show Tammy is a perfectionist.
Thank you.
Omer lesson, no. Oh, that's funny.
One sec. Okay. Let's see.
I didn't see this message before someone mentioned that I'm so into Golang. No, my preferred language, like starting like 2 years ago, is Golang. But before that, I was more into like Python, C, and somewhat C++. Even though I'm not a big fan of it, because it's just you can do too many operation. But I don't know. Since I got into like a simple language like Golang, I just really like it more.
Simple.
The number of ways to do something is less.
I feel like it's getting cut here too.
Oh, it is.
Okay.
Can we go to the original video?
Yeah.
Oh, actually, no. We can look. We can just look at the original images. Yeah, that's very fast.
Okay, you know what? Let's do this. Let's... Would the offset ever be height times 2?
I don't think so.
Let's say we knock this down to 1.5.
So even, I think in the Python implementation was also 1.5 as well.
Yeah, but then we had to increase it because sometimes it wouldn't cut it. Okay, now I think.
Let me increase mine to 2 and see what happens.
Okay, let's see, this works, this works. That worked. That worked. That worked. Yes!
So 2.
We got the right deltas.
So 2.
Now watch this. We're almost there. We just need to remove this extra 1000 padding. And I think we actually have finished today's objective.
Nope.
Well, we finished most of today's objective. Let's see. Come on, generate. Do we have any cuts? If we have no cuts, I will be very happy.
I
Okay,
think we don't.
Omer, since you're the comic expert, you tell me if you see any cuts.
There's literally just pages, so just make sure the pages lined up. So if anyone is
It
wondering why,
worked. That is incredible.
Mhm. So if anyone is wondering why people will actually pull a video of a comic that just I think this is like 8 pages. What happened is the YouTube videos are the bad translation one, and when the good translation come out, they're usually on websites and the pages are separate. But if you want to go ahead and read the rest, you just use YouTube because you can get everything. And it's also a fun idea for today as well to
Yeah.
showcase you can, in
I
theory, solve what you have if you know enough coding and some logic around it.
Yep. I am very happy that we got this done. We have achieved today's objective using a combination of 3 different programming languages to achieve a single task. So we used Swift
So
to glue things together, we used Python for all the operations that would take way too much code to do in C, and we used C for the stuff that had to be super, super high performance. That was pretty incredible. And as you can see, we now have a single file which contains all of our stuff. As a matter of fact, something you could actually do is, like, for example, if let's just say, like, in our live stream today, I am actually going to put this code up on GitHub, so you will have this in the description in a moment. But even if let's just say it wasn't there, what you could do is you could actually screen record me scrolling through here, right? And you could use this software to stitch that into a single image of code, and then OCR that to a final code file. But yeah, that is really fascinating to see. So
you know
what
what's
else do you
funny
want to
today?
What?
Your implementation is a mess compared to like if
It
we'd done
is.
this like purely in C.
But
Oh,
think about it. Well, here's the thing. If we were to fix this copying logic in C, and if we were to package this up into one Xcode project where it's just input output, it would be cleaner. It's just that right now, because of the fact that we were just trying to get it to work, we didn't really care about if it looked good or not. It looks like this, but we can get it to look good.
At least it worked.
Yeah,
That's,
this
that's
is
a big factor.
pretty nice to see.
So how many lines of code is this in total for you?
I don't know because there's so many comments. If I were to remove them all.
70?
Okay, so within Swift we have 65. In C we have about 58, and then Python's like another 10.
Okay, so much less than Golang. Golang.
Even after we have 3 languages, it's less than Golang.
What technically I'm doing a lot of like time in, right? So
Mhm.
like my main function is like 70 lines, and a lot of that is just to check time in, and also multi-threaded.
Interesting. Well, who knows? Maybe in the future we'll be bringing this even further and accelerating it. If we can somehow get a way to load frames in faster and deduplicate faster, that would be exceptional. But for now, we're not going to go against FFmpeg because that is the gold standard of the video industry, I guess. But for now, this is a great start, and as you can see, it works. We were able to calculate the delta of the scrolling between different frames, and we were able to stitch it into a single image. Anything else to add, Omer?
I'm just laughing at one of the comments. Zeus is like release the binary in the homebrew, and you can stitch videos through install, whatever we're gonna call this.
Okay, that would actually not be a good. That would not be a bad idea. Release this as a binary where people can use this generally to stitch together videos where they scroll. Good idea. We'll take a look into it in a little bit. Apart from that, let's just quickly see if there are any more important questions to get to right now. Zeus says, just really quickly, Kotlin has JVM overhead while Swift is LLVM binary. Technically, you're right, but Kotlin can also be compiled through LLVM. So Kotlin is a great language for that. It can do native compiles, although the default is using JVM. I'm also just quickly checking, making sure that there's no other major question that we want to answer. All right, so I think that's all for now. Omer, do you see anything else that you want to answer right now?
No.
Perfect. Great. So in that case, I believe that will end our 5th episode of live coding. Once again, thank you very much everyone for joining in today. I do hope you enjoyed. I will be posting the source code in the description, so if you have your own videos where people are scrolling through comics or really anything else, it could be code, it could be a social media feed, whatever it is, doesn't really matter. You can use this code and you can go ahead and use it in order to stitch together into a single image. All right, so thank you very much once again for joining in today. Remember, if you would like to be notified whenever we do these live streams or release new content on my channel, do subscribe and turn on notifications. That way you actually know when I release new content. There's some really exciting stuff coming up towards the end of this week and next week again on our live stream on Wednesday. So make sure you stay tuned for that, including all sorts of really fun stuff of how you can use GPUs for general purpose compute. But of course, again, thank you very much, Omer, for joining, and goodbye, everybody.
Goodbye, everyone.